Immunochemical technique, radioimmunization and ELISA. Immunology is a study of immune responses by which animal defends itself against invasion by the foreign organisms. The immune response can be divided into two general types: the antibody-mediated response and cell-mediated response. The immunochemical techniques employs the antibody involved in the humoral antibody. The substance which is produced in response to the foreign antibody invasion is called antibody, and the foreign organisms are considered as antigen. The immunochemical techniques are available to detect or quantitate the antigen or antibody. They are radioimmunization and enzyme linked immunosurveillance and are two important sophisticated immunoassay techniques available, which are used to measure the hormones, drugs, tumor markers, antigen in biochemical samples. Radioimmunoassay is one of the most important techniques used in the clinical biochemical field for the quantity analysis of hormones, steroids, and drugs. Any immunoassay techniques involves a reaction between the antigen and specific antibody. This immune technique utilizes radioactive isotopes atoms of a given element with the same atomic number but different with different atomic mass are called isotopes. Example: carbon. Radioactive isotopes are stable isotopes which emits particles or electromagnetic radiations. Radioisotopes are unstable isotopes which emits particles or electromagnetic radiations. For example, carbon-14, hydrogen-3 emits beta particles, iron-125, iron-131 emits gamma particles. The instruments which measures the radioactivity are called scintillation counters. Beta emissions are measured in liquid scintillation counter and gamma rays in the gamma counters. The radioactivity is measured as counts per minute. The unit of expression of radioactivity is curie, millicurie, microcurie. The half-life of a radioactive element is defined as a time taken for the activity to fall from its original value to half the value. The radioactivity is measured as a count per minute. Unit of expression of radioactivity is curie, millicurie, microcurie. The half-life of radioactive element is defined as the time taken for the activity to fall from its original value to half of that value. Half-life of some commonly used isotopes are as follows: hydrogen-3 120 days, hydrogen for carbon-14 வந்து 120 days, iodine 125 60 days, iodine 131 வந்து 8 days. Antibody is a protective protein which is produced in an animal's body in response to the foreign substances, and it is capable of binding with that of a foreign substance. Antigen is a foreign substance that simulates the production of specific antibody molecules when introduced into the animal body. Principle of radioactivity: this technique is based on the competition of between the unlabeled antigen and labeled antigen for a limited number of antibody. At the end of the reaction time, the reaction tube would contains both antigen antibody complexes as well as a free antigen. Under standard conditions, the amount of the labeled antigen bound to the antibody will decrease as the amount of unlabeled antigen. The antigen in the patient sample increases. This is explained by the example. The radioactivity of a bound labeled antigen is measured. Therefore, the radioactive count is inversely proportional to the unlabeled antigen concentration. In the example given above, the number of antibody and the labeled antigen is kept constant. Only the number of unlabeled antigen is increased. The same principle is followed in the assay system. The standard curve is constructed by performing the assay with the different concentration of standard antigen solution taken in different tubes. Hormones like thyroxine, triiodothyronine, T3, insulin, cortisol, renin, aldosterone, follicular stimulating hormones, and luteinizing hormones, etc. The tumor markers like prostate specific antigen, alpha fetoproteins, vitamins, drugs like digoxin. Advantages and disadvantages of radioimmunoassay. Advantages: the method is highly sensitive, very small concentration, even up to picogram level of antigen can be measured. It is highly specific method. Disadvantage: highly costly of equipments and reagent, the short life radioactive hazards, and assay is very long. Enzyme linked immunosorbent assay or enzyme immunoassay. The ELISA The enzymes are used to label the antigen and or antibody. There are two types of ELISA: single antibody method, double antibody method. Single antibody method, the known amount of enzyme labeled antigen and no unknown amount of unlabeled antigen mixed is allowed to react with the specific antibody attached to the solid phase. There is no competition between the labeled and unlabeled antigen for binding with a limited number of antibodies. After specified time of incubation, the wells are washed. During washing, the unbound antigen washed off with buffer. After the complete complex has been washed, the buffer, the enzyme substrate is added and the enzyme activity is measured by measuring product formed colorimetrically. A double antibody test ELISA, the unknown antigen is allowed to bind with a specific antibody attached to the solid phase. Now the second antibody, which is labeled with the enzyme, is added. This antibody binds with already bound antigen, forming an antibody complexes. This antigen is now sandwiched between the two antibody. After washing off the excess of antibody, the enzyme substrate is added. The enzyme activity is measured by measuring the product formed colorimetrically. The enzyme activity is directly proportional to the amount of antigen present in the test tube. Indirect ELISA, the antibody molecules of antiserum binds to the antigen and the remaining material is washed away. When this is exposed to enzyme labeled anti-immunoglobulin antibody, result in binding to any specific antibody molecules observed from the original serum, resulting in degradation proportion to the amount of specific antibody in the original serum. Application of ELISA. ELISA is used in clinical biochemistry to measure hormones like thyroid hormone, insulin, reproductive hormones, pituitary like follicle stimulating hormone, luteinizing hormone, thyroid stimulating hormone. It is used to measure the level of tumor markers in serum like alpha fetoprotein, prostate specific and HCG, CEA and CA125. The ELISA is used to study the infectious diseases like direction of bacterial toxin, viruses, hepatitis B surface antigen. For the assay antibody in the serum in infectious diseases, example Epstein-Barr viruses, Ebola viruses, antibacterial antibody, example Brucella and Salmonella. For the assay of auto antibody, example anti-DNA, anti-nuclear antibody. Difference between RA and ELISA. ELISA is cheaper than RA, suitable for use even in small laboratory. Lacks radiological hazards of RA. Reagents have more specific life compared to RA. ELISA is equally sensitive and specific as RA. Material used in ELISA: solid phase, plastic tube or micro titer tube. Enzyme horse radish peroxidase, for which substrate is hydrogen peroxide. H2O2. The alkaline phosphates, for which substrate is para-nitrophenyl phosphate. Electrochemiluminescent assay processes are known to occur with numerous molecules including compounds of ruthenium, osmium, rhenium and other elements. Electrochemiluminescent is the process in which highly reactive species are generated from stable precursor at the surface of an electrode. These highly reactive species reacts with one another, producing light. The development of electrochemical luminescent antigen immuno assay is based on use of ruthenium to tris complex and propylamine. The final chemiluminescent product is formed during the reduction step. The chemiluminescent reaction that leads to the emission of light from the ruthenium complex are initiated electrically rather than chemically. This is achieved by applying a voltage to immunological complexes that are attached to the streptavidin coated microparticles. The advantages of electrically initiating chemiluminescent reactions is that entire reactions can be precisely controlled. Use of ruthenium complex. The electrochemical luminescent technology uses a ruthenium chelate as a complex for development of light. A salt of ruthenium tris or stable water-soluble compounds. The bipyridyl ligands can be readily modified with a reactive group to form activated chemiluminescent compounds. For development of electrochemical chemiluminescent immunoassays, N-hydroxysuccinamide ester is used because it can easily couple with the amino group of protein, haptens and nucleic acid. This allows the detection technology to apply to a wide variety of analyte. The electrochemiluminescent reaction at electrode surface. There are two electrochemical active substances, the ruthenium complex and the tripropylamine, are involved in the reaction that leads to the emission of light. Both the substrate remains stable as long as voltage is not applied. The chemiluminescent reactions of ruthenium tris and tripropylamine occurs at the surface of full platinum electrode. The applied voltage creates a electrical field which causes all materials in the field to react. The tripropylamine is oxidized at the electrode, releasing an electron and forms an intermediate tripropylamine radical cathode, which further reacts by releasing the proton H plus to form a TPA radicals. The internal ruthenium complex also releases an electron at the surface of the electrode, thus oxidizing to form the cation. This ruthenium cation is the second reaction compound for the following chemiluminescent with the TPA radicals. The TPA and ruthenium reacts with one another, whereby ruthenium is reduced to ruthenium and at the same time forms a excited state via energy transfer. This excited state is unstable and decay with the emission of a photon at 620 nanometer to its original state. The reaction cycle can now start again. Propylamine radical reduces to byproduct which do not affect the chemiluminescent process. The TPA is used therefore we must be present in the excess. The reaction is controlled by diffusion of TPA and the amount of ruthenium complex present. The TPA is the electrical field is depleted. The signal strength is slowly reduced once the maximum is reached. Although during measurement the TPA is used up, the ruthenium ground state complex is continuously regenerated. This means that the ruthenium complex can perform many light generating cycles during the measurement process, therefore showing an inherent amplification effect which contributes to the technology sensitivity. Many photons may create from one antibody complex. Advantage of ECL technology: enhanced sensitivity in combination. Short incubation time means high quality assay and fast result turn around. Large measuring range of 5 order of magnitude minimizes dilutions and repeat, reducing handling time and reagent cost. Application for the direction of all analyte provides a solid platform for menu expansion. Competitive principle: this principle is applied to analyte of low molecular weight. In the first step, sample and specific anti-T3 antibody labeled with the ruthenium complex are combined in an assay cup. After addition of ruthenilated T3 and septa within coated paramagnetic microparticles, the still free binding site of labeled antibody becomes occupied with the formation of antibody hapten complex. The entire complex is bound to the microparticles via intercalating to the biotin and streptavidin. After the second incubation, the reaction mixture containing the immune complexes is transported into the measuring cell. The immune complex are magnetically entrapped on the working electrode. However, unbound antigen reagent and the sample are washed away by the process. In the ECL reactions, the conjugate is a ruthenium based derivatives and the chemiluminescent reaction is electrically stimulated to produce light. The amount of the light produced is indirectly proportional to the amount of antigen in the patient sample. The evaluation and calculation concentration of antigen are carried out by means of a calibration curve that was established using the standard of known antigen concentration. Sandwich principle: the principle is applied. Serum is combined with the reagent containing the biotinylated TSH antibody and ruthenium labeled TSH specific antibody. During the incubation time, the antibody captures the TSH present in the serum sample. In the second step, the strepta within coated anti-magnetic microparticles are added. During the second 9 minutes time of incubation, the biotinylated antibody attaches to the streptavidin coated surface of the microparticles. In the third step, the reaction mixture containing the immune complexes is transported into the measuring cell. The immune complexes are magnetically entrapped on the working electrode, but unbound reagent and serum samples are washed away by process. In the ECL reaction, the conjugation is a ruthenium based derivatives and the chemiluminescent reaction is electrically stimulated to produce light. The amount of the light produced is directly proportional to the amount of the antigen in this patient sample. The evaluation and the calculation of the concentration of the antigen are carried out by means of calibration curve that was established using the standard of known antigen concentration. Bridging principle: This principle is similar to the sandwich principle, except that the assay is designed to detect the antibody bodies only immunoglobulin. This is accomplished by including bioattenuated and ruthenium labeled antigen in the reagent for which the target antibody has been affinity. In the first step, the serum antibody binds with the bioattenuated and ruthenium labeled antigen to form immune complex. The immune complex then reacts with streptavidin coated microparticles via bioattenuated antigen. In the third step, the reaction mixture containing the immune complex is transported into the messenger cell. The immune complex are magnetically entrapped on the working controls, but unbound reagent and serum samples are washed away by the process. In the ECL reaction, the conjugate is ruthenium-based derivatives and the chemiluminescent reactions is electrically stimulated to produce light. The amount of the light produced is directly proportional to the amount of the unlight in the sample. Evaluation and calculation of the concentration of antibody are carried out by means of a calibration curve that was established using the standard of known antibody concentration.